Welcome back. I'm Colin O'Flynn, and I'm doing part 3 of my E41 ECU teardown. So last time we got one of these ECUs. I opened it up, and in part 2 I actually got the PCB out of the enclosure. And what we also did is we took the PCB off fully and sort of pinned out what some interesting pins were. So, there's a bunch of stuff in down here, and there were some test pads that are actually part of the JTAG pinout and stuff like that. So could be useful for our further investigation. Now, unfortunately, what happened was that if you remember getting it out, there was a ton of flexing from this sticky stuff under here that stuck to the board. I didn't know you basically would have to cut it to remove it safely. This helped kind of delaminated both some of the pads and a bunch of the balls. Anyway, nevertheless, what I was able to do was actually to go ahead and reball what was left of the BGA. So this is the BGA off this board. And what I'm hoping to use this for is to be able to do stuff like boot it and check, there's this boot assist module that's basically like a serial bootloader that's on these devices, and we want to take a look at how that's configured. There's a default password for that. Normally it's going to be changed, but we want to explore how that's actually done and look at some interesting hardware hacking techniques that might be able to help us here. So I'll look at that in a second. But for now, we're going to get another E41 ECU, and this time we have one that is not damaged, so we can take a look at it and happily explore this device. So, we have the not damaged ECU. We now know what these test points are, so we can start to do some interesting stuff. Now, to power it up, we are going to take a look at what's pretty obvious up here. There's some big power pins. All of these are one big blade. So there's one big blade that clearly goes to the big ground plane. So that's going to be obviously ground. And then there's a few different larger blades here. So rather than fully guessing, what I'm actually going to use is a automotive reference. So in this case, alldata.diy.com. If we look up the part number of this ECU, you can figure out, particular truck it's from. Here we have a 2018 Sierra 2500 V8 6.6. And if we go down here somewhere, did I pass it already? We'll find the pinout for the big ECU connectors. So there's a few pins on that. Oh, that's too far. We want the one that has 4 big blades. There we go. So these pins 1 to 4 are bigger blades, and then we have these huge blades, pin 5 and 6. So pin 6 is ground. So we sort of get the orientation of this connector is basically how it looks on the screen here. So this is the ground big blade. And if we look back at the pinout, you'll see that's basically the bottom big blade here, pin 6. So we now need the battery voltage, and you can see pin 4 is the battery positive voltage. The other big ones are kind of like output fused supplies to various stuff. So the ECU can typically turn off, some sensors and stuff for saving power. Obviously, these things are all about, saving power because you have this battery voltage that's actually directly running into this. So I'm going to move this around so it's not blocking as much stuff that I need. This is the plus 12. So if we connect this up, you can see the current usage here. It jumps for a little second, which I think is just, charging a capacitor or something. It's not actually booting. We need this thing to actually boot because we want to be running the microcontroller. So that's not happening. If we go back to our data sheet here for the connector and for the ECU pinout, there's one more pin we need, which is this run crank ignition voltage. again, because this is a ECU, what you have is that it's not actually going to turn on until it sees like a power request, you know, the user turning the power key. So that's that pin right here. And I'm just going to touch it. Oops, do a better job here. I'm just going to touch it to plus 12 volt. And when I do that, you should see the current jump up. So you can see that, and if I release it, it actually stays for a second. It's, you know, it starts to boot, and then like if you turn the car off, it stays alive for a second, and then you can see it fall back down. So all we're going to do now is just tie that right in to plus 12. Oops. And I'm just using these little clips, so they're a little more finicky than soldering. But there you go. So now I can cycle on and off the ECU, and I have this pin out. Okay, so what was the point of all that? Well, if we go back to our previous video, you'll remember I figured out some of these pins. One is this boot config pin 1. I also had found the RXA and RXD pin. And so the RXA and RXD pin are part of this boot assist module. That we can use this serial boot mode. So this is what we want to explore in this video, is the real point here. And to do that, we need to do a few things. I'm just going to move this up a little. We need to strap, so this boot config pin right here. And again, that was from the last video is how I found this. There's a source of 3.3 volts over here. So I could strap that and reset it to enter boot mode. What I also need is a way to actually talk to it. So what we're going to do is we're going to use a little clip on some sections to get access to the RX and TX pins, and then use a nice little micro UART down here to actually talk to this. So this is running at 5 volts. So that's one of the reasons I'm using the micro UART. It's also isolated, so it's a really nice piece of gear. So in the previous video, again, I mentioned that this LIN transceiver down here has, let's turn the power off when we do this. This has the RX TXA line. So if we get our little alligator clip just right, and that seems to be pretty good. We can now add the RX and TX lines to that. So that device we can pull up the data sheet for and see a few things here. Where's the pin out? There we go. So you can see there's a sleep pin that we can just short to ground. So if I take my sleep pin here, which is pin 2, and we're going to take that and we're going to short it over here to ground. Oops. This will put the transceiver to sleep just so that it doesn't drive actively the TX or RX pin. Now if we go back here, we can look that pin 1 RX is the receive data output. So that's the output pin to the microcontroller. So this means we should be connecting our TX of the micro UART to that pin, because this would be the output also going to the micro controller. So we could put the TX pin here. And the RX pin is the other side there. So I'm just going to do that right now. So I'm going to take my RX pin from this micro to here, because we're bypassing the LIN transceiver, and we can chuck that in. Okay. We also need 5 volts for this, so this thing needs a reference because it's isolated. So I had scoped out earlier and found there was a little handy 5 volt source right here. So what I'm going to do is I'm just going to use this little 5 volt source to power, let's see, somewhere here we have, there it is, VN. So we have a reference voltage for the actual transceiver, and we need, actually, we can probably not enough of this pin sticks out. So just do that. So there's our 5 volts. And finally, we should have some sort of ground. So let's use this. So it's starting to look a little dodgy, but you know, we'll make do. To be our ground over here. Okay. So in theory, when I turn this on, what I'm going to get is access to the UART on the microcontroller. So nothing's going to really happen yet, though, because we haven't enabled the boot assist mode. So the final thing I'm going to do is enable the boot assist mode with a little jumper. And we need to know what to actually send it. So if we look back at our data sheet here for the micro, what you can see is they talk about the serial bus mode. Basically, if that boot config pin is set appropriately, it goes into serial boot mode, which is what we want. It's going to expect any sort of a password. So how we send this is that serial boot mode. We're going to use a baud of 24,000. This is the oscillator value here. And it's pretty straightforward. The protocol is literally just we send it data, so it describes it up here. It sends the 64-bit password, and then you send start address, download code, etc. All we have to do is we can just check if it accepts the default password or not, and if the password fails, we'll stop echoing stuff back. So we should see some change in what we see. So let's just adjust the baud rate. Okay, and this is off. So now all we have to do is use the pin that I identified earlier. Hope we don't blow anything up, which is always a risk here. Okay. So in theory, that strapping is just done at reset, and that's it. So let's check the default password. So if we go up here, it talks about the default password is feed face cafe beef. And I've tested this, so it's FEED-FACE-CA-FEBEEF. So feed face cafe beef. Let's try sending that in. This guy, and try to strap it into bootloader mode. So we use the pin, connect it to 3.3, and we just check if, if I send FE, 1, 2, 3, 4, 5. So for some reason it seems to be responding with a. Let's just make sure it actually powers off. I suspect it was in some weird mode or something here. Grab this to positive voltage. Okay, so we're working now. So FE feed face cafe beef. And if I send a final 00, you'll see that was not echoed. So it did not accept that password. Basically what's happened is that it's gone into bootloader mode, and then the password's failed, so we're out of luck. So that means these devices do not appear to be programmed with the default bootloader password. All right, so let's explore this a little more. And to do that, I'm going to take this guy off the table. And I have another trick here, which is to actually grab, just put that down, the dev board for this device. So right here is a dev board for this actual particular chip of interest. So what this guy will let us do is take a look at the device running in this thing, and in fact I can insert the specific device that I pulled off the other ECU, and we can try to get that working. But before I do that, why don't we take a look at a Virgin device. So this is the same micro that we have. Oops, things falling here. The same micro we had, and pin 1 goes up to this side, pin 1 to this side. So we'll put that there, and yeah, we could leave it like that. That's fine. We're going to take our our serial port, and we're going to just move it over here. And we're just going to connect up ground, VIN, and TXRX. I forget the order here, but we'll see in just a second. And rather than having a pin, this uses a little dip switch up here that I've set it right now to go into the boot config mode. So all we need now is to actually give this guy some juice. So if we give it some power, we should be able to take a look at how the bootloader should work, right? So power this thing, and there's a little reset light because there's no power. So one of the things that took quite a while, actually, I had a few different dev boards I test. This is the reset out LED. It seems very basic. These devices are relatively complex, and what happens is they come out of reset, so they check the power supplies and stuff before they come out of reset. In this case, I actually tried a slightly different dev board. I was able to get a lot easier than this one was harder to find. Nothing seemed to work. I really needed this dev board in particular to get this whole thing to work. Once I have this, you can see that it does come out of reset just fine. So we have the dev board, we have this, we have power. The last thing we need to look at is if I pull up my terminal and we do that same experiment on this Virgin device. So let's reset it, and let's see if I got the TXRX backwards, which I must have. And again, this is a 5-volt TXRX, so that's the kind of... Okay, so we're now into the bootloader mode. Let's reboot it because I don't know what happened. So feed, face, cafe, beef, and if I send 00 after, you can see this echoed back. So now it's accepting the second part of the download procedure. So this is what did not work on the device pulled from the ECU. So that was the default password. That default password just worked. What we want to try now is, let's see if we can get the bootloader, the device up that I pulled off, the old ECU. So I turn the power off here. This is the device pulled from my other ECU. There's enough balls left. I should have checked what was damaged. Unfortunately, the JTAG pins were damaged on this, but that's presumably locked as well if they're using non-default passwords here. So, oops, just get that guy in there. Okay, check pin 1 so I don't blow stuff up. That looks good. Again, this is strapped to enter the bootloader by default. And finally, let's just reset it. Check it comes out of reset. And if we send feed, face, cafe, beef, and 00. So you can see that's not echoed. So that's just the local echo timeout. Ooh. So you can see here what's actually happened if I take a look at the reset pin. I believe this guy times out and resets eventually. So it actually looks like, so you can see it's not echoed. This little echo here, so you can see right away there's an echo. Actually, what we're seeing is the device resets eventually. I don't know if that's an external watchdog on the thing, but for example, if I send a totally wrong password, which again will have the same effect, and eventually it'll stop echoing. I didn't count how many bytes this is. Okay, there we go. So it eventually stops echoing. And what's actually going to happen eventually is that the device is going to reboot on me. It's kind of too quick to see, but there's a little flicker on the reset pin, and after that flicker happens, it's then looking for a password again. So we see a bit of an echo, but that's not it accepting the password. That's just like a artifact of the system timing out and rebooting. What we should see is, like with the correct device, how it immediately accepted the second byte. So where to go from here? The next stuff I'm going to be looking at is modifying this, either making my own dev board or modifying this board to let me do differential power analysis, and to inspect what happens when the correct versus incorrect password is inserted into this device. So that's kind of my my next steps here. I've also got, so actually already pulled out, I haven't done a video on it yet, the E91 ECU, and have another ECU in this series coming as well, so to sort of see what different devices are used. It's not the same device, and they have some variations, so one attack won't work across the families, which makes sense based on the tuning. You know, the E41 has been tuned quite a while ago, and it took a while for the E99 to become available. So this one was pretty long-winded, I know, and it didn't really go anywhere. But I did want to take people through, you know, the process of actually prodding at the ECU itself, and then looking at the two devices, and seeing that boot protocol. So hopefully the next in the E41 series, we'll be taking a look at DPA, and I'll probably will post a E99 teardown to give you a feel for how that guy is looking right now. But thanks for watching.